Hello again everyone, welcome back to ptet.chemistry channel. So I'll continue this tutorial video on section beta of MCQ on this 9.2, which is just group 2 chemistry in my classification. In this type of questions, comparing three statements, there's the very common thing in the section B MCQs, paper 1 for the Cambridge International A-Level. This does not mean that they are not helpful if you are doing any other curriculum, because MCQs are actually very good assessment for whether you understood the materials you have learned or not. That's okay, because they usually test more than just one bit of the learning objective. In this kind of MCQs, we have option A, B, C, D, where option A is all three statements are relevant to what they're asking. 1 and 2 being B, 2 and 3 being C, and just 1 being D. That's relevant to whatever they're asking, yeah? So in this first question, we have magnesium oxide. So there's Mg2 plus or 2 minus. In fact, I've just given it away. Magnesium oxide in part of your chemistry vocabulary is an ionic compound. It's also part of your case study ever since your GCSE or O-level or IGCSE. Part of your case study into ionic compound. In A-level, it's part of your case study under state of matter. Quite a lot of solid state stuff that you need to know about their structure and bonding and their properties and their uses. So MgO is used as a refractory lining in a furnace. So an example of a furnace is a blast furnace. They are used in the extraction of iron, extraction of metal, extraction of iron metal from iron trioxide, which you have done in your previous level of chemistry before you enter A-level. So why do we use MgO? Okay, so a blast furnace is got to withstand high temperature, okay? Very high temperature. So it's got to do with the high melting point and boiling point of the MgO, all right? Well, we don't want it to boil off because we want it to remain, so we're just looking at melting point. We want it to remain as a solid, okay? So it's just down to the melting point. It's got nothing to do with thermal conductivity because you are not using it to conduct or whatsoever. Moreover, it's a giant ionic structure, so as long as you stay in the solid state, it will never conduct because you don't have free ions anyway, all right? Your goal is not to melt it. Your goal is for it to withstand the high temperature. Due to the high melting point, it won't melt, and you don't want it to melt before the stuff that you are trying to do in the blast furnace, okay? So that's just option D straight away. So this next question is basically about a basic calcium phosphate. So I guess the term basic there refers to the alkaline solution there, as in basic being alkaline, and that is your calcium phosphate, which is calcium 2 plus. Phosphate with the ATE is PO4 minus, that is phosphorus plus 5 oxidation state. I mentioned this repeatedly as part of phosphorus oxide chemistry or phosphorus chloride chemistry in general periodicity. If you watch the other videos, this is phosphorus plus 5. You could show it, but ideally you should be able to pick this up from practice after practice. So there's phosphorus equal to plus 5 oxidation state. This is 2 plus, this is 3 minus. If you do something called lowest common multiple, LCM, from your primary school mathematics, your common factor is going to be 6. Plus 2 to become plus 6, you will need 3 of it. Minus 3 to become minus 6, you will need 2 of it. Only then you get this ratio, Ca3PO4 twice. Only then the charges balance out and you get a compound with no overall charge. That's not the point of this question. In older people, you get calcium ions. They are lost from this basic calcium phosphate, weaken the bond structure. And in such case, we administer strontium salt. So we use strontium salt. Strontium replaces the lost calcium ion. Strontium replaces the lost calcium ions. So what do we know about strontium? So in group 2, you have beryllium, magnesium, calcium, strontium, barium, blah blah blah. Radium, I think, below it. Which statements are correct? So we want the strontium to replace the lost calcium ion. So option 2 says strontium hydroxide is less soluble than calcium hydroxide. So in AS level, in your group 2 specification, you are asked that you should state the solubility of the group 2 hydroxide down group 2. Down the group 2, the hydroxide become more soluble. You are also asked to state about the solubility of the group 2 sulfate, which is M2 plus SO42 minus, M2 plus 2OH minus. That's why the stoichiometry is 1:2. Stoichiometry here is 1:1. Formulas are very, very important, yeah? Okay, so they have opposite trend, and both trends of which are required to be stated by you as part of your learning objective in AS chemistry. So this statement itself, strontium hydroxide is less soluble than calcium hydroxide. Strontium is below calcium. Strontium hydroxide is more soluble than strontium hydroxide. This is a wrong fact, okay, because the factual thing is already wrong. So it is wrong chemistry, we can rule it out. Therefore, you are only left with one option, which is just D, because if number 2 is wrong, then the answer must be just number 1. And we can also think about number 3, why number 3 is wrong. There is ionic, there is definitely ionic, Ca2 plus OH minus, and then the calcium phosphate, they are ionic as well. And then they are covalent. Of course, they are covalent. When you have PO43 minus, what do you think PO43 minus is? PO43 minus is phosphorus, like that, minus, minus, minus. And you also have hydroxide, which, what do you think hydroxide looks like? Okay, hydroxide is like that. That is your covalent bond, covalent bond, covalent, covalent, covalent bond. Okay, so there is covalent bond within the polyatomic ions, as well as within the OH itself. There's also ionic bond between the oppositely charged ion. But what you don't have is, you do not have metallic bond, because none of these are elements. Metallic bond only exists between metals, and metals are pure substance, elements. These are compounds, these are not elements. All right, so automatically we know 3 is wrong anyway, just to convince yourself. All right, moving on to the next question. So this is asking which magnesium compound, which is a group 2. I was about to write the Roman numerals, so this is what we use now, numerical number. Okay, loose mass. Okay, loose mass, that means emit or produce gases when you heat it. Okay, so we know magnesium nitrate, there is magnesium 2 plus, nitrate is NO3 minus. Your LCM is 2, so you need 2 of that. That is just MgNO3 twice. All right, magnesium carbonate, I mean, you don't need to do this all the time, but you know, I'm just showing you in case you're very weak in formula, all right, which you shouldn't be. If you want to do well for your A-level chemistry, you should have a good vocabulary of your ions. You should have a good vocabulary of the different formula of products that you can get. All right, so out of all these 3, this one can be decomposed further, I can tell you that, but I can show you the equation for decomposition of nitrate. It will give you the group 2 oxide plus the NO2 gas, which is a brown gas. So you will see a brown gas, and you will see, you don't see oxygen, by the way. You need to test for this colorless gas. When you hit a solid and you get a brown gas, you must test for this, because you don't see the colorless gas. Yeah. Balancing the equation, 2 nitrates will give you 2 NO2. There is 1 oxygen, there's 4 oxygen. 1 plus 4 is 5, there is 6 oxygen. You must have diatomic oxygen, because there's oxygen molecule at room temperature and pressure. So half times 2 is just 1. 5 plus 1 gives you 6, and that is balance. That is solid, gas, and gas. These are very commonly asked in a theory paper, not just in AS, but also in A2, because there's a big advanced group 2 chemistry in A2 section, yeah, or whatever section that you're doing, or whatever curriculum that you're doing. Yeah. So this one will give you magnesium oxide and CO2 gas. And yeah, of course you test the CO2 gas with lime water, which would turn it milky or chalky. Yeah. And the magnesium oxide does not decompose further. All right, it just stays magnesium oxide. Otherwise, this will decompose further. In this question 9, we have a firework, and when we lit it, we have a fuel and an oxidizing agent react. So in this firework, magnesium is the fuel, barium nitrate is the oxidizing agent. So what happened with that is that you can imagine the magnesium being oxidized by this, so you will no longer get the magnesium. So instead what you will get is, you can imagine you getting magnesium nitrate, which is your group 2 nitrate. However, in the presence of such heat, because as you know, firework is a example exothermic reaction, right? It'll give out heat, that's why you get all those smoke and stuff, and you also generate a lot of light energy as well. So there's your group 2 nitrate. It will not survive the intense heat in which this reaction will proceed under. And what will happen is, we know the group 2 nitrate will decompose to give you magnesium oxide and the NO2 gas as well as oxygen gas. So balance your equation. Solid magnesium oxide, gas, and you get half mole of oxygen gas. So we know the magnesium nitrate will not survive when you lit the firework, okay? Neither will the barium nitrate, where the barium nitrate will get reduced because it has oxidizing agent, but that is in that reaction. But you might have some barium nitrate left over, or whatever, the barium nitrate that still hasn't undergone the redox reaction. It can also decompose to give you barium oxide and NO2 and oxygen gas in a similar manner. As the group 2 nitrate decompose fairly easily, alright, under heat, which is the kind of situation where you have when you have the fireworks being lit up, okay? Especially in the presence of a fuel. So combustion of a fuel is exothermic. There's a lot of energy. There's enough to get this decomposition going. So we know barium nitrate can decompose. We know magnesium nitrate can decompose. We will most likely not see traces of the magnesium nitrate. And even though the barium nitrate is involved in a redox reaction to get the magnesium to magnesium 2 plus, which is likely to form magnesium nitrate, whatever barium nitrate that is still left over, that is still unreacted, or they are still continuously being reacting, what will happen with them is that they could also decompose in the presence of heat. Essentially, I can rule out number 3 because what? Because the magnesium nitrate would not have survived such high temperature, so I wouldn't have seen the nitrate at all, even though this is magnesium 2, even though this is what magnesium would have been oxidized to. I don't see 3, therefore the only sensible answer will be option B. This is the last question of this 5-question series. So we have this electronic structure of the outer shell, or what they call the valence shell, of radium. So radium is just below radium is just below barium in the periodic table. So you are in N equal to 7, so you're in the 7th shell, you're in group 2, you're in the S subshell, and you're in group 2, that's why you have S2. Which statement will be correct for radium? The element will show an oxidation number of +2 in all its compound. That is the nature of group 2 chemistry, so that is correct. The element will decompose water, liberating hydrogen. So think about the reaction with water. Okay, as you go down group 2, in fact as you go down any group of the metals will become easier to lose the electrons because you have weaker effective nuclear charge due to more shells, and your shielding increases because you got a lot more shells down the group. Weaker effective nuclear charge for the outermost shell electrons, therefore it becomes easier and easier for you to lose the outer shell electrons. So for example, if I write the general M for group 2 metal, reacting with water, reactive metal with water, if I have M2 plus and OH minus, I need 2 of it, and I give off hydrogen gas, and to balance the equation will be like this. The solid will dissolve, I'll get an aqueous solution, I'll see bubbling or effervescence because I see gases being produced. Sorry, I don't see the gas being produced, I see the bubbling of the effervescence because the gas itself is colorless, yeah? So this is a redox. A lot of students don't know this, but this is a redox reaction. The metal itself is 0, oxidation state, the hydrogen is +1. There is the hydrogen as an element is hydrogen 0. This is a group 2 hydroxide, so in its compound is forming a +2 oxidation state. So it does decompose the water, liberating hydrogen. So decompose is quite an unusual word. I would have thought it would say react with water, but it does liberate the hydrogen, and it's going down group 2, so it's fairly reactive with water as well. Yeah. Radium has the higher first ionization energy. That is incorrect. It will have low, because going down group 2, as we mentioned, more shells, more shielded valence electron, weaker effective nuclear charge. It becomes easier for you to lose the outer shell electrons. That's why it becomes easier for you to lose the outer shell electrons and become cationic. Oxidation is loss of electron. It becomes easier for you to lose your outer shell electrons. This is the end of this 5-question tutorial. If you found them helpful, check out the other topical playlists as well and the other great content on the channel. Click the button on the bottom right, subscribe to the channel, share the channel widely with friends, your various chat group, your social network, which is far more extensive than mine. Thank you for watching and thank you for sharing. See you in the next video.